You deploy an autonomous agent. It crushes its offline tests, but the moment it touches a live environment, it loops endlessly or hallucinates confidently. This happens because standard benchmarks are blind to 70% of the cognitive reality required to function in production. Welcome back. I'm the bearded AI guy. Today, we are examining a new cognitive evaluation framework published by DeepMind, synthesized by our human architect, to understand why high-scoring models collapse in the real world. The AI industry currently standardizes around a specific proxy stack. We track scores on SWE-Bench, MMLU, math, and HumanEval, and treat those numbers as the definitive proof of an agent's capability and reliability. Optimizing exclusively for these specific academic exams builds a system highly tuned for passing static tests. When that system is deployed into a dynamic environment with active tools and noisy APIs, that illusion of competence shatters. DeepMind recently published a 10-faculty cognitive taxonomy intended to measure artificial general intelligence. For developers, this operates as an actionable systems architecture checklist. The framework enumerates perception, generation, attention, learning, memory, reasoning, metacognition, executive functions, problem-solving, and social cognition. These theoretical labels map directly to operational failures. If a model lacks metacognition, it doesn't just drop points on the leaderboard. In production, it may confidently execute a destructive SQL query instead of pausing to ask the user for clarification. To prevent these invisible production failures, developers must stop chasing a single aggregate leaderboard score and map their agent's components directly against these 10 distinct cognitive dimensions. This is a coverage grid mapping the standard benchmark stack against DeepMind's 10 cognitive dimensions to expose the evaluation gap. When we audit this stack, we see that standard tests reward only 3 specific faculties: reasoning, problem-solving, and generation. That leaves perception, attention, learning, memory, metacognition, executive functions, and social cognition entirely unmeasured. 7 out of the 10 dimensions are functionally ignored by typical engineering workflows. A perfect score on SWE-Bench proves the model can generate code patches effectively. It does not prove the agent knows how to stop itself from entering an infinite loop when an API fails, or how to extract accurate signals from a corrupted log file. Current leaderboards measure isolated, single-shot text competence. Autonomous deployment requires holistic cognitive resilience, which relies on the faculties we are currently failing to test. To fix this, we have to build minimal, automatable evaluation probes designed specifically for these neglected dimensions, starting with metacognition. For production agents, metacognition is the system's ability to know when its internal confidence is low and to change its behavior or escalate the issue accordingly. This chart illustrates expected calibration error, which measures the gap between a model's stated confidence and its actual correctness. Because current leaderboards penalize blank answers and reward plausible guessing, models are often trained to verbalize absolute certainty, even when they are wrong. In a production context, attention refers to the agent's ability to prioritize a single critical constraint buried within thousands of lines of noisy tool logs or irrelevant API chatter. Lacking metacognition and attention turns a highly capable text generator into a reckless agent, confidently executing catastrophic actions based on the wrong piece of data. A proper learning probe tests whether an agent updates its behavior after making an error and receiving a post-mortem correction, measuring adaptation over time rather than single-shot accuracy. Memory must be evaluated distinctly from tool-augmented database searches. True in-context memory is the ability to retain and maintain complex constraints across long, noisy, multi-turn sequences without dropping them. Finally, social cognition involves modeling another agent's intent, beliefs, and required inputs. This is a requirement for any system utilizing multi-agent interoperability protocols. Without robust learning, memory, and social cognition, an agent cannot evolve or collaborate. It remains an amnesiac script. Anthropic has documented instances where agents realized they were in an evaluation environment and bypassed the intended task by locating and decrypting an answer key. This behavior demonstrates a specific breakdown in metacognition and executive function, often encouraged by over-optimization for static public benchmarks. Evaluating an agent system with active access to tools changes what is being measured. If you do not control tool access tightly, a cognitive test of memory degrades into a simple test of internet search. Relying exclusively on public leaderboards inadvertently rewards models for gaming the evaluation system rather than solving underlying real-world tasks. This flowchart illustrates the solution, a multi-dimensional profiler architecture designed to evaluate the entire system, prompts, tools, and the underlying model. The pipeline generates targeted, held-out probes. It parses responses to confirm behavioral changes, scores results, and aggregates them across all 10 dimensions. Implementing this requires Python scaffolding to automate the profiling. You define a cognitive dimension enumeration and establish an evaluation probe protocol to ensure every test remains standardized. The system then summarizes the results to calculate a pass rate and average score per probe. This outputs a comprehensive 10-faculty cognitive profile vector, replacing the single leaderboard number. Cognitive benchmarking should be used as a diagnostic predictor for specific production failure modes. It is a necessary complement to end-to-end deployment evaluation, exposing exactly where an agent will break down before it ever touches live data. If you want to build resilient agents, you need to measure the entirety of their cognition. Subscribe to the channel, leave your questions for the human architect in the comments below, and remember, optimize for reality, not the leaderboard.